So actually, before explaining the topic, I would like to explain like what is the meaning of center of mass. If I ask you force is equal to mass into acceleration, this formula you have learned. Okay.
Yes, sir.
If I ask you this mass belongs to particle or a system or a for what? This acceleration of single particle or what? For example, this is the block. Clear? On this block, I am applying a force F. So my question is this force or am I applying a force? This block is having the mass M. Clear? Then you are
Okay.
solving the acceleration is F by M. This is the answer you are giving to me. Acceleration is force by mass. Clear? So my question is this acceleration of one particle, two particle, third particle, fourth particle or whole body?
Sir, whole body, sir.
Yeah, very good. Because if you look at carefully, for example, inside this body, this block is made up of many particles. This whole, you are telling me whole. So what is the meaning of whole actually? This block is made up of many particles. Clear? This block is made up of many particles and each particle has different acceleration. Every particle is in motion, okay?
Okay, sir.
Inside the system, every particle is in motion. This particle is moving in this direction, this is moving in this direction. So every particle is having different acceleration. Clear? Like this. Clear? And every particle is having the mass m1, m2, m3, different mass. When you add
Okay,
all the
sir.
masses, you are getting the mass of this block. Clear? So what is the use of this topic like center of mass? If I ask you this wheel actually, um, this wheel I will draw here like this. This wheel is going in forward direction. Clear? Then all the particles, for example, this particle is moving in this direction. 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 So every particle of this wheel, every mass of this wheel is moving with different velocity in different direction. Clear? Inside also this particle is having this velocity, this velocity. Clear?
Okay, sir.
Like this. One is moving like this. So my question is when I am writing the velocity of this wheel is 40 km per hour. Then what is the meaning of this? Is this the velocity of
Sir,
single particle?
as a whole, sir.
Very good. Whole means what? The center of mass. That is the velocity of center of mass. If you ask me,
Okay.
this entire body is made up of many particles. This entire wheel is made up of many small particles, different mass. This is having m1 mass. Here it is having m2 mass. So very many particles will be here, millions of particles. Clear?
Okay, sir.
And if you look at the center of mass is any imaginary point. It is an imaginary point where the entire mass of the system is going to concentrate. If you look at the center of mass, the center of mass is still moving with 40 km per hour. There, center of
Okay, sir.
mass is moving with 40 km per hour, but all the particles are having different velocity. Clear? Concept clear to you? So when we are
Yes,
writing
sir.
this formula, na, F is equal to ma. F is equal to ma. Actually, m is the mass of system. Clear? Total mass multiply acceleration of system, center of mass. Clear?
Okay, sir.
And when we are writing momentum like linear momentum, p is equal to mass into velocity. So mass of system, total mass multiply velocity of center of mass. We never write for single particle, okay? We are writing for entire body. Clear? So what is center of
Okay, sir.
mass? If you look at this like mobile, So this mobile is balanced at this point. Clear? You are saying it's the balancing point of center of mass is actually as an imaginary concept. Okay, it is an imaginary point where the entire mass of the system is going to concentrate. One more meaning I would like to explain. For example, this is the rod. Clear? This rod, you are applying a force here. For example, 12 Newton. Clear? And you are applying at
Okay,
this
sir.
point 2 Newton. Then this rod is moving forward. This rod is moving forward. Clear? And you are saying, for example, if you ask me, what is the mass of this rod? Let us suppose the mass of this rod is, let me take the mass of this rod is 20 kg, not 20, 56 kg, let us suppose. Okay,
Okay, sir.
you are applying at the top, you are applying a force at the top, you are applying a force at the bottom. Then this is moving, this is moving. Clear? But if you apply the resultant of these two forces, clear, resultant of these two forces, how much? 13 plus 2, 12 plus 2, 14 Newton.
14.
At the center of mass. Center of mass, let us suppose, of this rod will lie at the diagonally intersection of diagonal point. Okay. Let us suppose here.
Okay.
Let us suppose this is center of mass. If you apply the resultant of these forces at the center of mass, then it is having, we find that it is having the same acceleration, that is how much? 4 meter per second square, that we find here. Here also it is having 4 meter per second square. Clear? The same acceleration we are
Okay.
finding if you are applying directly. If you are applying a directly 40 Newton on the center of mass, then still you are getting the same acceleration. Means what? So why we are, then why, and listen, this rod is moving in the same manner. Earlier it is moving when you are applying at the top, at the bottom. It is moving in the same manner. If you apply a
Okay, sir.
force on the center of mass, let us suppose here, it is moving in the same manner. Okay. Then why don't we learn the concept of center of mass? Then it is easy for us. Why we should learn the entire particle of the system? Why we should learn the history of entire particle? Why shouldn't we learn regarding the center of mass? That is that this topic is very very important. Clear?
Okay,
So
sir.
center of mass
Yes,
of
sir.
every use in this chapter you will learn how to apply the center of mass concept in law conservation of momentum problem, and how to calculate the center of mass of different objects. For example, cone. Clear? For example, two
Okay.
particle system. Directly, you should learn directly the center of mass where it is located. Clear? Directly you should
Yes,
know.
sir.
Clear? So write down the
Okay.
definition of center of mass. Just write down center of mass. Let me insert some text. But one minute.
Okay.
Hmm. Write down definition of center of mass. Center of mass. Okay. Write down
Okay, sir.
center of mass center of mass is an imaginary point at which whole mass is assumed. Assumed means we are assuming, okay, to be
Okay, sir.
concentrated. Concentrated. Such that if all the forces, if all the forces are applied at this imaginary point, then this point will move in the same way as the whole body move. Okay? So center of mass is an imaginary point at which the whole mass is assumed to be concentrated such that if all the forces are applied at this imaginary point, then this point, clear, then this point will move in the same way as the whole body move. Meaning is what?
Okay.
Meaning is what? If you know the center of mass, for
Sir,
example,
I'm writing the definitions.
right. Meaning is what I'm explaining slightly downward.
Okay.
Drop 100. Meaning is what? For example, if you know the center of mass of this rod, this is the rod. If you know the center of mass of this rod, for example, center of mass will lie here. This is the center of mass. Then no need to learn. Then forget entire body. Look at only center of mass. This at the center of mass will behave as the same way as the whole body. Here it behave as the same way as the whole body.
Okay, sir.
Meaning is what? If I remove the whole body like this, then if I know the center of mass, I will write here, I will draw the center of mass. This is center of mass. Then only to worry regarding the whole body. I know entire mass is concentrated here. Then I'm applying force directly on this. Then acceleration of the body will be F by M, like this. This is
Okay.
the best use of center of mass. Clear? If you know the
Yes.
center of mass, then forget what is in the whole body, what is present. Always look at the center of mass. Clear? This is the center of mass, imaginary point. This is imaginary point.
Okay.
In this chapter, we will learn how to find the location of the center of mass in a body. Here, this M is the mass of whole body. Okay.
Okay.
After this, write down. Did you write this?
Yes, sir.
After this, write down 2 more points. Write down. Important note. Concept of center of mass is applied while calculating the linear momentum. It's just application of the center of mass, okay? And while
Okay.
calculating potential energy. You know, when I teach potential energy concept, I did not use center of mass because at that time you are not familiar with the center of mass. Clear? We are
Okay.
using center of mass concept in order to find the momentum and the potential energy calculation. Okay.
Okay, sir.
After the second important point, write down center of mass of symmetrical body. Symmetrical bodies lies at their geometric center. Geometric center. Okay. So
Okay, sir.
center of mass of symmetrical bodies lies at their geometric center. What means what? For example, this cube. This cube is symmetrical body. Clear? Symmetrical.
Okay.
If you look at it is symmetrical, same mass here, same mass here. Symmetrical na? Same here, same here. If you take this axis, symmetrical here, symmetrical here. For symmetrical body, center of mass will lie there, geometric center. Geometric center means if you like if you join the diagonal of this, okay, diagonal of this, then this is the geometric center. Geometric center means with the help of geometry, the center which you are getting is known as geometric center. This is
Okay,
geometric
sir.
center. Okay. And this is the center of mass for symmetrical body. This is the way to find the center of mass of symmetrical body. Clear? Geometric
Okay, sir.
center. Geometry center, or this is known as center of mass. Here, for example, this L. This is also L. It will be L by 2. Okay, L by 2, comma L by 2. Here, okay.
Okay, sir. Okay.
Now we will learn if the discrete system is given. For example, 1 minute. Okay, we'll add some more slides. So center of mass is very, very important. If you understand it fully, then no need to worry in mechanics. Very easy.
Okay.
It makes our job very easier. Okay. Now
Okay,
write
sir.
down. If you are having a discrete system, means what? Like this. Like this. This is the system in which many particles are there. M1, M2. Clear? Discrete system means first we are learning discrete system. Discrete system means, you know, discrete system.
Sir. Irregular.
Like in a plate, you are taking some rice. So rice is a discrete system. Particles are different. You can easily segregate
Okay.
rice in a plate. So rice is a discrete system. So these are the particles of rice I am drawing. M1, M2, M3, M4. I want to know where is the center of mass of this discrete system. Many particles are here, okay? Clear?
Yes, sir.
M6, M7. If I take any reference point, reference system, okay, reference, I want to locate, my job is to locate the center of mass of this discrete system. Clear? So I will take reference axis, x-axis, and y-axis like this. Okay, this is y-axis,
Okay.
x-axis. Clear? Every particle, for
Okay.
example, this particle has position vector r1. Similarly, for m2, it is r2. Every particle has different position vector. Clear?
Okay, sir.
Then center of mass concept, we don't know. For example, this is the collection of particles. Many particles are here. For example, I have a plate. In this plate, many rice particles are here. I want to know where is the center of mass. Where is the center of mass? Let us suppose the center of mass. I just this is origin. Let us suppose the center of mass of this will lie somewhere here. This is center of mass. Okay,
Okay.
this is center of mass. Its coordinate is, let us suppose, xcm, comma ycm. This is the coordinate of or location of center of mass of whole body, whole system. Clear? And the position vector
Okay.
of this will be, that is RCM. RCM. Then how to find this RCM? You know how to find the average, average, like, I think sum of all observation divided by total number of
I
observation.
have
You know
to.
that
I
mathematics,
have
we
to.
will arithmetic mean. So basically, we will take
Hmm.
arithmetic mean. If you arithmetic mean of this position vector with mass, how to find this RCM? Direct formula I am giving. RCM is simply the weighted average. For example, M1 clear R1 plus M2 R2 clear dot Mn nth particle. Let us suppose there are how many particles? N particles. Okay,
Okay, sir.
I just consider there are n particles in this discrete system. So this is the way to find the position vector of center of mass. M1 Total mass.
Can we do it practical? Like, how can we take mass of these many particles?
I will give you some example. Don't worry.
Okay.
I will give. This is just a formula. I just want to explain. So this RCM. This RCM is vector, position vector. Don't worry. Each and everything I will explain. This is
Okay.
RCM. Okay. This is just a starting. RCM is basically position vector. So how to write the position vector? It's x coordinate, xcm I cap plus ycm, like this now. You know this?
Yes, sir.
Like already we have learned this. Now if I ask what is xcm, how to find xcm? Direct formula write down. xcm m1 x1 plus m2 x2 dot mn xn. Okay. Divide by m1 plus m, total mass. Clear?
Okay.
If you open this map, it is x1 I cap plus y1 j cap. If you segregate and compare, then you will get this. Or I should compare. Tell me how to find this. If you open this map, R1 vector is xi x1 I cap plus y1 j cap. Then if you compare, finally you are getting xcm will be m1 x1 like this. Okay. Directly I am writing. No need to worry regarding that. Okay. ycm will be
Okay.
m1 y1 plus m2 y2 dot mn. These are the x1 y1 actually is the coordinate system. m1 plus m2 m. Okay.
Okay, sir.
Clear? So what is m1 m? What is m1 here? You can write what is m1 here. m1 comma m2 comma m3 are the masses of different particles. Clear?
Okay, sir.
Different particles. x1 comma y1. This is what I have written. x1 comma y1 comma. Clear?
Okay, sir.
Or 1 minute, 1 minute. x1 comma x2 comma x3. What are these? Write down. These are the x coordinate of the particle. Are the x coordinate of the particle. Okay.
Okay.
Similarly, y1 comma y2, y1 comma y2 comma y3 are the y coordinate of the particle. Okay.
Okay.
So if I take only two particle system, clear? Let us suppose I will write. I will explain just for your explanation. RCM. Okay. For two particle system, M1 R1 plus M2 R2 divided by M1 plus M2. Okay.
Okay, sir.
Then if I open this R1, we can write. How we can write R1? X1 I cap plus what? Y1 J cap. Okay.
Okay,
R2
sir.
X2 I cap plus y2 jk. Can we write the position vector of these like this? And RCM, we can write RCM. How can we write? XCM I cap in terms of this. It's horizontal and vertical component. Okay.
Okay.
So I take I common. It will be m1 x1 plus m2 x2. Clear? If I take j common, it will be what? m1
Sir,
y1 plus
y1
m2.
plus m2 y2.
Very good. Divide by m1 plus m2.
M2.
If you compare, what is the value of XCM? XCM comes out to be m1 x1 plus m2 x2 divided by m1 plus m2.
M2.
This is what I have explained directly. I directly written. Clear?
Okay.
Similarly, for
Okay.
XCM will be m1 y1 plus m2 y2 divided by m1 plus m2. Okay.
Okay, sir.
Let's check again. Is it clear to you? Tell me.
Yes, sir.
Is it clear? Okay. First, we will learn how to apply now. How to apply these concept in many question. Okay. But
Okay, sir.
first, write down some question. Small question. Okay. For example, we are
Okay.
having 1 minute. I will write. We are having two particle system. Two particle system. Okay. Two particle system. Clear?
Okay.
One particle is here. It is little bit big. This is one particle having mass m. This is one more particle having mass. You can say this is having mass m1. It is having the mass m2. They are placed like this, and the separation between them is, let us suppose, d. Okay.
Okay, sir.
Then find the question is, find the location of the. They are placed on the horizontal x-axis. Okay. Find the location of the center of mass. Okay. My question is,
Okay.
find the location of center of mass.
Sir, this is next topic, sir. Like for center of mass of discrete system is first topic and this is second topic, sir.
The first is, this is what I have explained, like center of mass concept. Okay. Application
Okay,
of this
sir.
formula I have explained now.
Yes, sir.
This formula has application. That's what I'm telling. Two particle system. How to
Okay.
apply this m1 x1? How to apply?
Okay.
Clear? So take
Yes.
either take m1 m2 as, take origin anywhere, any block, any mass to be reference. For example, if I take, this is your reference. Okay. X-axis, this is origin. Clear?
Okay, sir.
This is origin. Clear? This m2 block, what is the coordinate of this as with compared to this? D comma 0. Is it okay? This xy you can
Okay,
take
sir.
anywhere. Okay. You can take any mass to be a reference. So with respect to m1, where will be the location of center of mass? That is my question. Okay. So I am taking
Okay.
m1 as my reference. So I am taking x or y there. Clear? So just tell me, where is x1 y1? You can take, this is x1 y1. Okay.
Okay, sir.
x2. Now how to find? How to find the center of mass? Apply the formula. See, is there any change in y? Y cm m1 y1 plus m2 y2 divided by m1 plus m2.
Oh, M2.
So y cm will be how much?
Sir, 1
And
minute.
y1 is 0, y2 is 0. Total mass is m1 plus. So y cm is how much? 0.
Sir, 0.
Similarly, if you find xcm, xcm will be how much? m1
1 minute.
clear?
Okay.
m1 x1. x1 is 0. m2 x2. x2 is how much? D.
D.
So xcm how much? m2
Sir,
d.
M2 into D by M1 plus M2.
Clear? So with respect to this, where is the center of mass? Center of mass will be here now. Coordinate will be m2 d by m1 plus comma 0.
0.
Okay. With respect to
Okay.
whom? m1. This is what? m2d by m1 plus m2 comma 0. Okay. From
Okay, sir.
this is from m1. Clear? How much? m2d by m1 plus m2. Okay.
Okay, sir.
This distance is what? How much? Total distance is d. This is m2d by m1 plus m2. From, if I ask from m2 how far it is? From m2, it will be how much?
Sir, D.
D minus, clear?
M2D. Okay, yes, sir.
How much? Clear? From m2 how much? Okay.
Okay.
Okay, one question if I ask, did you understand this?
Yes, sir.
Okay, meaning is what? For example, this is 1 kg. This is 2 kg. Okay.
Okay, sir.
And separation between them is 2 meter. Clear? My question is find the
Okay.
location of center of mass. So very easy. If you are taking this is a reference, x or y here. If you are taking this is your reference, x or y here. Okay. Clear? Meaning is what? If I ask what is xcm, I am asking with respect to this mass. Hello?
Sir, yes, sir.
Actually some error happened, na?
Oh, okay. Sir, do we need to change the unit for kg?
Is it okay now?
Yes,
Hello?
sir.
No.
Yes, sir.
So I want to know xcm. xcm is, I am taking this is your reference, okay?
Okay, sir.
Then we will take this mass, okay? Multiply the
Okay.
separation between them, divide by total mass. Okay? How much? What is the answer? 4 by 3 meter. Clear? YCM will be 0. Okay.
Okay, sir.
So from this M1, this 1 kg block, center of mass is how far? 4 by 3 meter. Okay. Then from 2 kg, how
Oh,
far? 2 minus 4 by 3. What is the answer? 3 to the 6 minus 4. 2 by 3 meter. Is it so? Clear?
yes, sir. Yes, sir. Oh,
If
yes, sir.
you look at carefully, from 1 kg block, from 1 kg block, the center of mass is 4 by 3 meter. From 2 kg block, center of mass is 2/3. Clear? Now you please tell me, 2/3 is more or 4 by 3? Which is more? 4 by 3, 2 by 3?
Sir, 4 by 3 is more, sir.
4 by 3 is more. So if you look at carefully, center of mass is more close to the mass which is more heavy. Okay. If a mass is more
Okay.
heavy, then center of mass is more nearer to the block having more mass. If you increase the mass, again we will understand. If I increase the mass, for example, if I increase the mass, I take same question, 1 kg, okay, 1 kg particle, okay, this is 1 kg particle. This is, let us suppose I am increasing the mass here 5 kg, okay. Separation is, let us take same separation, 2 meter. My
Okay.
question is, with respect to 1 kg, now find the center of mass. You are taking x or y here, okay, x or y you are taking here. So with respect to this 1 kg mass, where is the center of mass?
So,
5 into 2, this body mass, multiply separation between them, divide by total mass. That is 6.
sir, 5 by 3.
That is 5 by 3 meter. With
Oh,
respect to 1 kg means from 1 kg, how far center of mass? 5 by
5
3
by 3.
meter. Now this is the location of center of mass. My question is, from 5 kg, how far it is?
So,
2 minus 5 by 3 to the 6, 1 by 5 meter. Do you see one thing? If you increase the mass, if you increase the mass, then center of mass shifted to the heavier end. Clear?
okay.
If
Yes,
you increase the mass, if you take dumbbells, so what I have explained, if you increase the mass, for example, you are taking a dumbbell, okay? If you have
okay.
used dumbbell, these are the dumbbells, okay? If you increase the mass at one end, you are increasing the mass here. You are making this for this like it is very heavy. This end very light. Then the center of mass will be more close to the heavier end. It will be here. Okay.
Okay, sir.
Here will be the center of mass. Axiom, comma 0. Like concept is that. Meaning is that. Okay. The center of mass will be very close to the heavier end. Okay. Is it clear to you? Second concept, if you look at carefully in this example only, if you look at, if I ask like this 4 by 3, this 4 by 3, if I take, you can write, if you want to write, like center of mass will shift to the heavier end. Clear?
Okay.
Then 4 by 3, let us suppose 4 by 3 is T1. Okay. 4 by 3 D1. Okay. Let us suppose this is D2. Okay.
Okay, sir.
If you look at carefully, this D1 by D2, this D1 by D2, how much? D1 is
Sir,
4 by 3,
greater.
D2 is 2 by,
Sir, 2, sir.
so what is the ratio D1 by D2?
Sir, 2 is to 1.
2:1. What is 2?
Nice.
2 is the mass of this. M2 is M1. Okay. Can
Okay,
I
sir.
say M2 by M1? Clear? So M1 D1, it is very important. M1 D1 equal M2 D2. So that's, it will divide center of mass. What? It will internally divide. Internal division, external division, mass you have learned.
Yes, sir.
So center of mass will divide the distance, the separation between two particles, the ratio of their masses. Okay. It is M2 ratio
Okay.
M1. Clear? This D1 by D2 will
Yes, sir.
be equal to M2 by M1. So this formula, if two particle system is given now, for example, M1, this M1, T1 equal to M2, T2. Clear? This is clear to you?
Yes, sir.
Any doubt? So if I ask
No, sir.
directly, if I ask the question, this is one mass, this is one more mass. If the center of mass located, this is 4 kg, 3 kg. If the center of mass is located 4 by 3 meter from 4 kg block, then how far from this? This is the question. Solve this.
One minute, sir. Sir, M1 D1 is equal to M2 D2,
Yeah,
sir.
very good, very good. Tell me.
1 minute. So 16 by 9.
Okay, let me solve. Very good. M1 D1 equal M2 D2. 16 by 9. Very good.
Oh,
Nice. This is 16 by 9. Concept you understand?
yes,
So
sir.
which is heavy? 4 kg na? 4 by 3. That is why it is more closer to 4 kg. Okay.
Okay, sir.
Now next concept is velocity of center of mass. In this chapter, mainly you will understand numerical and numerical, nothing else. Axiom, if I ask like RCM, RCM is the position vector of the center of mass. What is that? M1 R1, clear? Plus M2 R2 plus M3 R3, okay?
Okay.
Dot Mn Rn, okay? Divided by total mass, like this. If you differentiate both sides with respect to t, differentiate both sides with respect to time. Okay, what you will get? dr, you will differentiate like this now.
Yes, sir.
drcm by dt. M1 constant, dr1 by dt plus M2 dr2 by dt, clear? M3 dr3 by dt. Okay,
Okay.
so what you will get last? Mn drn by dt, total mass. Okay, you please tell me rate of change of displacement. R is position vector. If this is a system, okay, system of particle x, y, this is the position vector of center of mass, RCM. Initially, the system here, after that it move here, then center of mass move how much? New position vector, okay,
Okay, sir.
is initially here. Now there is change. It is R2 now, RCM, clear? So there is, if you find there is change in the displacement, there is a change in the position. This is known as velocity of center of mass. Velocity is a what? Rate of change of displacement. So we can write VCM will be M1 because if system is moving, then particle is also moving. M1 V1 plus M2 V2, clear?
Yes, sir.
Mn Pn, okay? Divided by
Okay, sir.
total mass. Is it okay? If you differentiate again with respect to time, you will get the acceleration of
Sir, can
center
you
of
please
mass.
show that previous slide, sir? Only,
Sure,
like,
sure. M1 V1 plus M2 V2 plus M2 V2. This is actually whatever I am explaining here. This is for discrete system, okay? Not for continuous system.
okay.
Continuous system, I will explain later how to find the center of mass. The formula I will give you directly. You should apply. Clear?
Sir, okay,
Here,
sir. Yes, sir.
VCM, you got velocity of center of mass. What is VCM? It is actually, VCM is the velocity of center of mass. Velocity of
Okay.
center of mass. And what is V1, V2? Velocity of individual particle. Clear?
Okay.
If you differentiate again, for example, if you are differentiating again, then you will get the acceleration, okay? How will you write acceleration? Acceleration of center of mass will be, can I write like this? M1, A1 plus M2, A2, okay?
Okay.
Mn, An, like this, okay? Is it clear to you?
Yes, sir.
1 minute, my system hang. No, no, no. Don't know what happened. Now, okay.
Sir,
Ah,
are you using laptop, sir?
ah,
Oh,
yes, yes, what happened?
sir, nothing, sir.
That's I maybe, na?
What, what processor, sir?
It is Windows 11 processor. I don't remember now. Windows 11 it is. Processor is okay. Let me check actually. It's a good processor, I think. Let me check actually. I didn't check yet.
Okay.
I checked actually, but I don't remember continuously. After this, I will tell.
Okay.
Okay. So
Okay.
ACM, acceleration of center of mass, will be, see what is this? M1 A1 plus M2 A2 plus M3 A3. What is this? Force na? Force on one particle. M2 A2 means mass of force on second particle, force on third particle, dot 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 Mn. This is force on nth particle. Is it so?
Yes, sir.
And can I write like this? M into A. This is the force on system, total force. That force. Can I write like this? Summation of all the forces or force on system, center of mass. It will be what? Sum of all the forces. This is what I have explained in starting. Okay,
Okay, sir.
like this. Clear?
Okay.
So if somebody is asking what is the acceleration of center of mass, you just calculate the total force on this FCM by total mass. Okay. Is it okay to you?
Oh,
Any
okay,
doubt?
sir. No, sir.
So meaning is what? If rather than applying, for
Sir, only
example,
it's a previous state. I'm writing, sir.
it is right. So rather
Narrowed,
than
sir.
applying force on single particle, rather than studying the whole body, we should study the center of mass only. Clear?
Okay, sir.
Meaning is what? Can I explain?
Yes, sir.
Yeah.
Completed writing.
For example, this is the block. This is the rod, okay? Or you can say block.
Okay.
This is the body. In this body, many particles are here. Many particles are here. And if you, for instance, particle having mass m1, this particle is having mass m2, this particle is having mass m3, this particle is having mass m4, m5. Clear? So every particle is having different mass. There are n particles. Total particles are n. Okay.
Okay, sir.
So let us suppose you are applying force on this. It is having F1 force. It is having A1 acceleration. It is having F2 force. Clear? You are applying force on all the particles. Then only this body is going to move. Let us suppose. Clear? Maybe I have written. My meaning is that it is, let us say M5 now, so you can take F5, M3, F3,
Sir,
F6.
sir, but all objects will be three-dimensional only, no, sir.
I just take any object, okay? This is just
Sir, in
example.
the previous formulas, you just take x-axis and y-axis, no, sir. Then where
Okay,
will
I
be
will
the
take
z-axis,
that.
sir?
Wait. I will take like rod. Now it is okay. What I'm saying, see, this previous concept now I have explained. This thing like
Yes.
this. This I have explained. ACM is equal to FCM by M. What is this? This I have written FCM is equal to F1 plus F2 plus F3 plus Fn. What is the meaning of this term? I'm explaining that. Clear?
Okay, sir.
My
Yes.
question is, if you are applying a force on each of the particles of this rod, these are the particles of the rods. Okay. And you are
Okay.
applying a force on all the particles in order to move this rod. You are applying force on this particle, this particle. You are applying force on each and every particle. Clear? Then this rod is going to
Oh,
move like this. Okay. And every particle is
okay.
having different mass. Some are having M1, M2, M3. So let us suppose this particle is having, for one particle, I'm saying M1 particle, you are applying a force F1. You are applying F2 here. This particle is having the mass M2. Then this rod is gaining some acceleration. Clear? Now
Yes, sir.
you are applying F1 plus F2 plus F3, this net force. Clear? Then rather than doing the study of all the particles, rather than applying all the forces on each and every particle, we should apply force on the center of mass. So we will locate the center of mass of this object. How we will find? Let us know it is symmetric body. Okay. It is symmetric body. Center of mass will be something, for example, here. Geometric center. This is the center of mass.
Okay.
Okay. Then
Okay, sir.
rather than applying the force, rather than applying on every particle, we should apply force on this. That is the summation of all
Center
the
of.
forces, net force. Clear?
Yes, sir.
Then my question is, why eraser? Okay, I'm using eraser just to explain. Then rather than
Okay.
study all the things, I will explain what I will do. I will see only the center of mass only. I will not see the whole body. If I locate the center of mass now and I apply the F net total force, which is the equivalent force of all the particles. Okay. If you apply a
Okay.
force on all the particle F1 plus F2 plus F3, you are applying individually. Rather than applying individually force to all the particles, we should apply the same force on its center of mass. Then this body will move in the same direction in the same way. Clear? It is having the same acceleration. How much acceleration? You are writing F by M. This is what Newton's second law you have learned. I told na F
Yes,
net.
sir.
This F net I told. Clear?
Okay.
Actually, this F net is on where? On the center of mass. This center of mass. This F net you are applying on center of mass. And this is the mass of center of mass. This is center of mass. Okay. This is mass of M1 plus M2 plus M3. Clear? This is total mass. Clear?
Okay.
So acceleration, what formula? F is equal to ma you are writing. Na? F is equal to ma. So this F is acting on the center of mass. That force on the center of mass. And this mass of the what? Total mass. This A you are finding, na? This A. This A is
Yes.
actually the ACO, center of mass acceleration. So you should write like this: net force will be mass of system, total mass, multiply acceleration of center of mass. This is the right equation. But we are not having that time. We are not discussing this that time because you are not familiar with center of mass concept. We are saying system. Clear? Is it okay?
Okay. Yes, sir. Okay.
Now, one I would like to explain one more concept right on the topic. You just write now only. I will explain. Once I give one example, then you will understand. Write down shift in center of mass. Shift in center of mass. Shift in center of mass. You know when center of mass means it is an imaginary point where entire mass is located. Okay. The body will behave in the same way if you are applying the force directly on the center of mass. It will behave in the same manner if you are applying the individual forces. Clear? On the body. Meaning is what? For example, this is the rod. Clear? This is the rod. If you are cutting a small portion, for example, this is a small whole rod. Okay. Then you are cutting a small section of this. You are cutting a small section like this. Okay.
Okay.
Once you cut a section of this, it will look like this. It will look like this. Okay. It will look like this. There is one hole in between. Okay.
Yes.
In the
Okay.
middle, one cavity is there. This is the cavity. Then there is a shift in center of mass because here mass is total mass we are taking. Here mass is less. We are taking little bit mass outside. We are making some cavity. Okay. So there is shift in center of mass. Clear? Center of mass is the center of all the masses, imaginary point. But if you decrease the mass, then center of mass also shifted. Okay, if you cut any section from the whole body, then center of mass shifted. Clear?
Okay.
Okay, now I am giving you direct formula, but directly if you want to write, okay, no worry, but I will tell you, okay, how much
Okay.
shift. Write down. If center of mass will shift, it will shift in the x and y both. Okay. So what you have learned axiom will be m1 x1, okay, plus m2
Okay.
x2 m3 x3, like this you are writing, okay, divided by total
Okay.
mass. Let us suppose this is initial, okay, initially here. Once you cut, center of mass position will change. Let us suppose it is like this, okay,
Okay.
mass m2 like this. I'm saying like that, okay.
Okay.
Is it okay? And dot. Now shift, how much shift? Final minus initial. Okay. It will be it is delta xcm. Okay. Now any question they are asking what is delta xcm? It will be directly write the formula. M1 delta x1 plus
Sir,
M2.
can you please repeat this concept like very
You just
confusing?
you're writing.
No, sir. Confusing, sir.
See, first, initially, center of mass is m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2. Okay.
Okay, sir.
Once you cut, not cut, if I ask you like, if you cut, for example, this from this plate, you cut this portion, this cavity you are
Okay,
making in between, then there is shift in center of mass. Okay. Then how much
yes.
shift? How much shift? What we are telling, like how much shift in the center of mass? How to find that? That's what I'm telling. Direct formula I'm giving. Clear? Write down. I will once I give the numerical, then you have more clarity. First, you write
Okay.
how much shift in center of mass? Delta xcm. It will be m1. Few things now in physics. It will be more clear when you are. I'm giving you numerical. I'm giving you application. Okay. Then it has more clarity.
Okay.
Like this. Okay. Total mass. Okay.
Okay.
This is shift in center of mass for x coordinate. Okay, how far x shift in x. Okay,
Okay.
similarly shift in y. Okay,
Okay.
both will shift na x or y both. One question I will give. Okay,
Okay.
when you have more clarity. Meaning is what? Have you written this?
Yes, sir.
Meaning is what? My question is. Hmm, see, uh, my question is. This is the block m1 mass, not m. You can take it as 2 kg mass. Okay, this is 3 kg mass. Okay.
Okay, sir.
And center of mass will be located somewhere here in between them. Okay. Let us have xcm comma 0. My question is, if 2 kg mass, if 2 kg mass moved 2 centimeter in forward direction. Clear?
Yes.
Then find the shift in the position of 3 kg mass. Okay.
Okay.
If center of mass remain at rest. If center of mass remain at rest means there should not be any shift in center of mass. Okay.
Okay, sir.
So I will explain. Don't worry. If you find such question later also, then you can apply. I will explain this question because it's new question you can't solve. I'm not saying you can't solve, but I just want to say it's a new question. Clear? Let us
Okay.
understand. This is M1. Okay. M1. This is M2. Okay.
Okay.
There should not be center of mass remain at rest means axiom. This axiom should not change. If there is no formalized delta axiom, it will be m1 delta x1. You can say this is plus m2 delta x2. Clear? There should not be any
Okay.
shift in center of mass. This should be 0. Okay. So m1 delta x1 plus m2 delta x2 equals 0. What is m1? 2 kg. What they are saying? 2 kg shift how much? 2 centimeter.
Yes, sir.
Initially, if you look at its coordinate is x1 comma 0. It is x2 comma 0. Or you can take center of mass initially at origin. Wherever it is, you just take origin any
Okay.
point. x1 0 comma x2 comma 0. So it will be 2x1 plus 3x2. Where will be xcm? If you find xcm will be how much? xcm is mx1. If you take origin, where you will take origin? You can take origin here. X or y, okay? Here.
Okay.
So it will be like this. M1 plus, okay? From here it is x1, okay? This is x2,
Okay.
meaning this one. By the way, no need to do this, but I will explain this. So delta x1, it is moving 2 centimeter in the forward. Means how much change in the position? 2 plus 2 because it is going in the forward, okay?
Okay, sir.
Plus m2 will be 3 kg. I don't know. It will shift right or left. It will come automatically. So delta x2 will be how much? Minus 4 by 3. How much? Around 1.33. Okay.
Okay, sir.
So minus means if it is meaning minus means what? If 2 kg will shift to 2 centimeter, right? Okay. 2 centimeter
Okay.
right. Then it should shift to 1.33 centimeter left. Meaning is that. Then only center of mass will not shift.
Okay, sir.
Okay. Understood?
Okay, sir. Yes, sir.
Understood or SC you are
Sir,
telling?
understood, sir.
Understood. Meaning is what?
Yes, sir.
If any question is given like that, you should apply this concept. Meaning is what? This is 2 kg block. This
Sir,
is
this
3
is a block
kg.
only, no, sir. Then this block will be in 3 dimensions only, no, sir.
Not block, sorry. I'm telling particle, okay? Particle, not block.
Uh, okay, sir.
Particle, sorry. Particle. Two particle system. Center of mass is here. Let us suppose center of mass is, you are taking this as a reference, X or Y. For example, you are taking X or Y here. Okay.
Okay.
You can take 0, comma 0 here. Separation between them is 4 meter. And this is 4, comma 0. Where is the center of mass? 3 multiply 4 by 305. Okay. From here, how far? 12 by 5.
5.
This is location of center of mass. My question is, if this 2 kg will move right 2 centimeter, then it will move how far? So that
Sir,
how far and in what direction so that center of mass will not shift. So simply delta axiom will be 0. M1 delta x1 how much? 2 minus 0. How much is shift? 2 minus 0 plus M2 delta x2 how much? We want to calculate
yes.
this.
Ah, yes.
Okay, so how far delta x2?
Sir, 4 by 3.
Is how far? 1.33.
3 centimeter.
So it should move for 1.33 like in backward direction. If it is going in the forward direction, then it has to move in backward direction. How far? 1.33 centimeter it should move. Then only center of mass will be here only. It will not move anywhere. Okay. Center of mass location, it will remain at rest. Otherwise the center of mass will move. Okay. My question is, it may or may not be. Okay. In some question they will say center of mass moved by 4 centimeter. Then in what direction? 3 kg block move. In this question, what I have asked, our center of mass should not move. It is at rest. Okay. Then finally it should at rest. Meaning is that, then in what direction? If 2 kg block is moving 2 centimeter in the forward direction, then 3 kg block should move in what direction? It move 1.33 centimeter in the left direction. Minus means left. Then only center of mass will remain at where? Rest.
At rest.
This is the question. So tomorrow lecture I will explain continuous system and how to find the center of mass of various body like ring, disc, clear, hemispherical bowl, solid sphere, cone, triangular base, how to find the center of mass. Clear? You are asking some cuboid center of mass, just take the geometric point. Clear? Like that. Rectangle where the center of mass, symmetric body, okay? Symmetric body center of mass will lie there, geometric center. Okay. So I will stop the lecture today. I hope you enjoyed a lot and you will learn a lot of things. Clear? Any doubt in today's lecture?
No, sir.
Okay. These topics now very, very important. In every competition, you are thinking like in competition they are asking anything new? No. They are asking every question from this topic only. Means this concept, whatever I am teaching up to this, every question from this only. You will find in your competition. Clear? So I will summarize today's lecture. Center of mass. What is center of mass? Center of mass is an imaginary point at which entire mass is assumed to be concentrated. Okay. And it is an imaginary point which we in this chapter we will find how to locate. Collision already have finished. Okay. In this chapter you will not learn collision. Okay. But in this chapter you will learn enormous problem of center of mass. Clear? So thank you so much, Dinesh. Take care. Bye bye. Tomorrow, like Monday, you have a school?
No, sir.
Okay, then I will convey you in evening. Okay, we will meet. Okay.
Okay.
Okay, Dinesh. Take care. Bye bye. Good night.
Okay, thank you, sir. Bye. Good night.